I have to be extra careful with this transformer. Nice effect that's happening here is, I don't know if it's visible, my finger. It doesn't hurt, I can touch it, see the ionization. And I'm gonna check the transistor. The transistor is not hot. Schematic that we have in here is flyback driver. Transistor TIP142. Resistor 0 to 8.6 kilo ohm. Test the resistor limiting current on the base of this transistor. Capacitor that is separating DC from the base. One leg of the generator is connected to the base through this leg. The other one is connected to emitter. Collector is connected to the flyback primary and then to 0 to 36 volt. Secondary is connected to high voltage probe. This is the ground wire. This is the hot wire. On the scope we have a channel 1, channel 2, channel 3. Channel 1 is connected between collector and emitter. Channel 2 is connected between the capacitor and resistor emitter. Voltmeter is connected between a base and the emitter. That's what I have in here, is just a BNC connectors for each one of the channels. Channel 1, channel 2 and channel 3 high voltage probe. The voltage delivered from the generator measured at BNC connector channel 2, and we see in here channel 2 is 15 volts. The voltage between collector and emitter is measured at channel 1 and is 10 volt. The voltage measured on the channel 3, 12 kilovolts. Frequency of operation is the frequency of self-resonance of the flyback transformer, equals approximately 47 kilohertz. The power supply that is delivering voltage to plus and minus from 0 to 30 was set at 20.01 volts with the current drawn 0.036 ampere, 360 milliampere. The voltage between emitter and base 0.17 volt. We should put in here 0.17 of a volt. This transistor is able to withhold maximum 5 volts. Let's go to the scope. Channel 1, channel 2 and channel 3. With channel 1, division for the channel 1, 5 volts, 10 volts on channel 1. Collector and emitter. Channel 2, division for channel 2 is 5 volts, and we see approximately 10 and a little bit here, let's say 15 volts. This is channel 2 between the resistor and the capacitor. Channel 3 is showing high voltage and is set 5 volts, but a probe is rated 1 to 1000. 1 to 1000. We say we have a division of 5 volts. It is showing us approximately, it's approximately 10 volts. So it's 10,000 volts, not 12,000 volts. The frequency of operation, which is the same, 45, 46, up with 47. It depends how do I set it. I'm too far away right now to set it properly. More accurate reading, but the frequency of operation is 57 right now. The problem is that at 57 the current drawn is 2.69 amp, but If I lower it down just a little, look what's happening. I'm still at resonance. The division is 5 volts, approximately 10 volts times 1000 would be 10,000 volts. But the current drawn is 0.39. So if I'm tuning slightly up, trying to get to the most of the peak, I'm getting 5 amps of drawing, and I'm gonna show it to you. Okay, now the voltage is slightly bigger. I'm gaining approximately 1000 volts, less, but still resonance. See? Okay, try to start. Wow. 0.74 amp. The voltage is 20 volt. I didn't touch it. All I did is change the resonance frequency. So changing resonance frequency, I'm getting approximately similar voltage, but the current is smaller. This is a high voltage wire. Oh, this is 10,000 volts. How it works? Nice spark. I'm gonna look at the waveform and changes of the waveform while I'm sparking. I see the voltage drop creating that, but there is no much distortion. Let's see what's going on with the current right now. When I only touch that wire, the current rose. We have 1.6 amp and I'm releasing it. 0.77 amp. For me there is an indication that I'm giving extra capacitance from my body. The reason of this scientific investigation is being able to employ driver that gives me a high voltage and eventually run the device. I do have original power supply of IDAS, but I don't want to touch it. I just don't want to ruin this from that successful experiment in Lithuania. The generator that was utilized in this experiment is WaveTech. The frequency is set 51 kilohertz, but we could still go to 47 kilohertz. We're going to 47 kilohertz right now. At 47, that would be 340 milliamp. Good. See, I touched that, and with this frequency, I'm gonna touch it right now. Okay, it's 36. It's 94. 940. Now I'm gonna create a spark. Oops. So let's go to 1.3. I have to be extra careful with this transformer. Nice effect that's happening here is, I don't know if it's visible, my finger. It doesn't hurt. I can touch it. See the ionization. And I'm gonna check the transistor. The transistor is not hot. Okay, so you see the transistor in here. All of the connection. The potentiometer, which is the resistor, variable resistor, and the capacitor. 0.33 of a microfarad. I was playing with different one. Now this board is not connected. This was the original one that a year ago I was playing with. That was a generator, a bipolar generator I was utilizing. Practically, oh, I forgot to mention. Here is a spectrum analyzer. So with all of these values, you can see the curve on the spectrum analyzer, and that line is for the power measurement. And it says channel power. I created a channel from here to here, and that will give me a total RMS or dB per hertz. And I'm asking for average power. It's not the maximum power, it's an average power. So I'm gonna retune right now that. So I'm changing the frequency. Okay, you see that I'm changing the frequency. Now look what's gonna happen. Okay. In the window, I have a little bit above, the line is a little bit below. That's 47 kilohertz in line. Now, can I go higher? Yes. The current at that frequency is 0.36. Now I'm going higher. Wow. Yeah. Now the current is 1.32. Now going much higher. And the current is 5 amp. So see, by gaining almost nothing, I'm creating a very much high current. So for anybody who wants to experiment with a drivers, which would be a MOSFET driver, so FET driver, this one is NPN FET driver, don't go to the maximum. You're gonna ruin. Since yesterday I ruined 3, those are 2 remaining transistors. I don't have much left of them, so I gotta be very careful what I'm doing. And also I'm not gonna try to spend more money that I already spent for it. And thank you very much.